Hello friend, myself Prof. Sukhbur. Today we learn new topic capillary action. Firstly, in this video we can discuss what I mean by capillary tube, next capillarity or capillary actions. Then we can discuss possibility when the capillary tube is placed in a liquid, and last very important topic is application of capillarity. And another one, when capillary is dipped in liquid, two effects can be observed. The liquid level can rise in capillary, for example water in a glass capillary, or second effects, the liquid level can fall in the capillary, for example mercury in a glass capillary. These all point we can discuss one by one. Firstly, we discuss here capillary tube. What do I mean by capillary tube? Definition: a glass tube having a very fine bore is called capillary tube. A glass tube having a very fine bore is called capillary tube. Or definition here: a tube having very fine bore, this is nearly equal to 1 millimeter, and open at both ends is called capillary tube. Repeat again: a tube having a very fine bore nearly equal to 1 mm and open at both ends is called capillary tube. These are capillary words. Capillary words, how to derive? The words capillary is derived from Latin word capilla, which means here. The structure like here, for example blood capillaries, vascular bundles in plant tissue, these all example of a capillary. Then next definition we can discuss here: capillary action. What do you mean by capillary action? The phenomena of rise or fall of liquid inside a capillary tube when it is dipped in a liquid is called capillarity or capillary action. Repeat definition: the phenomena of rise or fall of liquid inside a capillary tube when it is deep in the liquid is called capillarity or capillary action. Then next point we can discuss here: the two possibility when the capillary tube is placed in a liquid. Here, if one end of a capillary tube is dipped in a liquid, the level of liquid inside a capillary either rise or fall as compared to the level of liquid in the outside of capillary in a container. First case here, if a capillary tube is dipped in a liquid which partially or completely wets the solid, then the liquid rises inside the tube. And second case here, if a capillary tube is dipped in a liquid which does not wet the solid, then the liquid level fall inside the capillary tube. These two possibility when the capillary tube is placed in a liquid. Some question asked on this topic: explain the two possibility when the capillary tube is placed in a liquid. Then what is meant by capillarity or capillary action, or what is a capillary tube? Then another interesting point is a application of a capillarity or capillary action. Some application given here, we can discuss one by one here. First application, a oil rises up wicks of a lamp by capillarity. Oil rises up the wicks of lamp by capillarity. Second application, cloth rags sucks waters. Cloth rags sucks waters. Sap and water rises from the roots of trees through the stem on account of capillarity. And fourth application of a capillarity, blotting paper absorbs ink due to capillarity. Fifth one, ink rises in a pen due to capillarity. And last application, water rises in a crevice of rocks due to capillarity. All these application of a capillarity. Question asked on this topic, give some application of a capillarity. Then another point we can discuss here, when a capillary is a dip in a liquid, two effects can be observed. Here first effects, the liquid level can rise in capillary. For example, water in a glass capillary. And second effect, the liquid level can fall in the capillary. For example, mercury in glass capillary. These two effects, when a capillary is deep in a liquid, we can observe these two effects. We can discuss one by one. Here, first one, first effect, the liquid level can rise in the capillary on the basis of pressure difference. The liquid level can rise in the capillary on the basis of pressure difference. See this diagram. Capillary in water after rise in level. See this diagram. Consider, suppose a capillary tube is deep into water. This is a capillary tube. Deep into water. Consider the situation before the movement of water inside the capillary. The shape of surface of the water in the capillary is a concave here. Shape of the, this is a concave. Let us consider point here, point A, point B, point C and point D as shown in this figure. Here this point A is just see here, this point A is just above the concave surface and inside the capillary. Point B here is just below the concave surface, just below the concave surface inside the capillary, and point C here, point C is just above the plane surface outside the capillary, and point D here, point D is just below the plane surface and outside the capillary, and below the point B here. Then we can discuss here P suffix A, P suffix A, P suffix B, P suffix C, P suffix D be the pressure at point A, B, C and D respectively. Since pressure on a concave side, since the pressure on concave side of liquid surface is greater than that on the concave sides, then we can write here P suffix A greater than P suffix B, because pressure on concave side of a liquid surface is greater than on the convex side. As the pressure is the same on the both side of a plane surface, then we can write here P suffix C is equal to P suffix D here, because pressure is the same on the both side of a plane surface. Then the point A and point C are the same level at the pressure at both this point in the same, then we can write here P suffix A is equal to P suffix C is equal to P suffix D. These all atmospheric pressure here. Therefore, we can write here this one, we can write here P suffix D greater than P suffix B, because P suffix D is equal to P suffix A. But point B and D are at a same horizontal level in the liquid. Therefore, in order to maintain the same pressure, the liquid out of the capillary flow into the capillary tube and rise above the point B till the pressure at B become the same as that at point capital D. Because there is a rise in a level of liquid inside the capillary tube. In this way, we can complete. First, the liquid level can rise in the capillary on the basis of pressure difference. Some question asked on this topic here. Explain the rise of liquid in capillary on the basis of pressure difference. Repeat again question. Explain the rise of liquid in capillary on the basis of pressure difference. And another effects, the liquid level can fall in the capillary on the basis of pressure difference. The liquid level can fall in the capillary on the basis of pressure difference. See here both figure. First one is capillary in mercury before drop in a liquid, and another capillary in mercury drop in a level. Consider a capillary tube deep in a liquid which does not reach the surface. This surface is mercury here. The shape of mercury meniscus in the capillary is upper convex. This is a upper convex surface. Let us consider 4 points as shown in figure. Here point A, point A, point B, point C and point D here. See here, point A is just above the convex surface and inside the capillary tube. Next one, here point B is just below the convex surface inside the capillary, and point C here is just above the plane surface outside the capillary, and point D is just below the plane surface and outside the point C. Let P suffix A, P suffix B, P suffix C and P suffix D be the value of the pressure at point A, at point A, at point B, at point C and at point D respectively, since the pressure on the concave side is always greater than that on the convex side. Then we can write here P suffix B greater than P suffix B greater than P suffix A, because the pressure on the concave side is always greater than that on the convex sides. Then as the point capital A and point capital C are at the same levels, we can see here in this diagram. Here point A and point C here are the same level. The pressure at both point is the same here, and it is the atmospheric pressure. Then we can write here this atmospheric pressure. We can write here P suffix A is equal to P suffix C. Consider equation first here. Between the point D and C, the surface is a plane. We can see here in diagram. Here point C and point D, the surface is plane here. Surface is plane. That time we can write here this condition. Second condition, P suffix A is equal to P suffix D is equal to P suffix A. Consider equation number second here. but the point B and D are the same horizontal level. Thus, in order to maintain the same pressure, the mercury in the capillary rushes out the capillary. Because of this, there is a drop in the level of mercury inside the capillary. In this way, we can explain the liquid level can fall in the capillary on the basis of pressure difference. Some question asked on this topic here. First question is, explain the fall of liquid level in case of mercury in a glass capillary. Explain the fall of liquid level in case of mercury in a glass capillary. Or question, explain fall of liquid in capillary on the basis of pressure difference. And another question also on this topic, explain the capillary action. We can explain two effects of capillary action. First one is the liquid level can rise in capillary, and another second one, the liquid level can fall in the capillary. In this way we can complete these all points here. What is meant by capillary tube, what is meant by capillary action, what is the application of a capillarity, and when a capillary is deep in a liquid, two effects can observe. First effect, the liquid level can rise in capillary, and another, the liquid level can fall in the capillary. In this way we complete all this topic. Today we stop here. Thank you.